Assalamualaikum and a very good evening. So today we are from Group A from Section 1 and 2 will present a project for the course PDA 30703 assisted by Dr. Ramzaini bin Abdul Rahman titled Water Heater. So here are the members of Group A, namely Juliana Chelsea anak Henry, Jessica Jatimi, Kishore Kumar anak lelaki Morgan, Siti Nofarha binti Muhammad Jailani and Siti Shakina binti Abdul Rahman. Based on the project title that our group has chosen, which is water heater. So I am Siti Nofarha, will explain a little bit about it and the objective to be achieved. To do this, the two main varieties of water heater storage, tank heater and tankless heater use different mechanism. A sizable insulated tank contains a water reserve in storage tank water heater. The water inside the tank is then warmed by heating element that is typically powered by gas or electricity. The colder water in the tank is displaced as the heated water climbs to the top of the tank and heats it up again. This cycle continues until the entire tank reaches the desired input, then ready for use. So basically this project objective are to measure heat input and output, calculate error, use fuzzy logic and then regulate supply to ensure that the target temperature is reached. And also functional block diagram of the entire closed loop control system is simplified by the end of the project.
Assalamualaikum, my name is Siti Shakina binti Abdul Rahman. I will discuss about chapter this literature review. So, from the literature review, we learn about principle of water heater. So, the working principle of a water heater in control engineering, managing the operation of a water heater, requires the integration of sensor. The fundamentals of control engineering involve incorporating sensor for recognizing important factors such as water temperature, pressure, and flow rate. As an array signal, the difference between the measured temperature and the set point is temperature curves. Measure the temperature of the water and provide input the control and the temperature sensor within the sensor enable for exact oversight. Okay, so a water heater heats cold water entering the tank using either the gas flame or electric component. A pressure relief valve presents an excessive build-up of pressure inside the tank, while the adjustable thermostat regulates and maintains the water temperature. So, my next slide is the figures of working principle of a water heater. Okay, so next we discuss about types of control system. So we have 4 types and the function. So first, flame sensor. Flame sensor is a safety device that detects the presence of a flame or fire in a furnace or boiler. Second, shut-off valve. Shut-off valve can be operated manually and are used for easy servicing of equipment without affecting the rest of the system. So third, water heater element. So they are typically composed the metallic rod, either straight or in a spiral shape. In case in a metal sheets, the element screws into the water heater and has a gas that slides. So lastly, we have a thermostat. Thermostat is used to control the temperature of the water in the tank. So it can be achieved this by controlling when the heating elements are turned on and off. Okay, so here we have a two-loop system, which is open loop system and a closed loop system. So an open loop water heater controller system is a one which the output, which is water temperature, is not immediately detected and supplied back to the controller for the modification. Instead of the system function without the continual feedback, and the control action is predefined based on a set of input circumstances. So open loop system is not available for this system. So that's why we choose a closed loop system. This ensures the water is heated to the desired temperature process of heating process, and the sensor is the temperature. So, if we have a temperature, we can prevent overheating and underheating.
Hi, my name is Raya Chelsea. My numeric is CD21010N. So, let's we go to the chapter 3, which talk about theoretical calculations and analytical procedure. As we can see from the picture, there are about block diagram where is Q desired as a input and Q actual as a output. So, for the temperature control, we choose PID control. There are Kp, which is Kp stand for the proportional, Kd plus Kd over S, where is D stand for derivative, plus Ki, I is stand for integral. So, for the thermostat valve, as a actuator, we got the transfer function is K over tau S plus 1, where is K is the heat transport coefficient, and tau is the time constant, and S is Laplace variable. And for the heating process, we got the transfer function is R over Rs plus 1. For the next picture, we got the graph diagram, which are that graph, the transfer function is given by the refer to the graph where is Q is proportional to the times, and where is tau is going up to reach the 63 degree. So the transfer function is all about the thermostat valve, where is K over tau S plus 1. So from the graph, we got that transfer function. And then for the heating processing, we got the input is Q desired and the output is Q actual. So from that, we create the equation by equation to create the transfer function where is R over Rs plus 1. And then we create the closed loop where is we multiple K over tau S plus 1 multiple R over Rs plus 1 to create the open loop system. So from that open loop system, we can analyzing the times and frequency response of the control system by using MATLAB and Simulink. So we follow the transfer function we create before, which are open loop system, where is Kr over Ts plus 1 and Rs plus 1. We assume the value into the equations, and we got the 1 over s power 2 plus 2s plus 1. So we use that equation for our analyzing in the MATLAB and Simulink to create the both plot, root locus and the Nyquist plot. That's all from me.
Good afternoon, my name is Jessica Jasmine Metric CD210062 from section 1 to group 8. Today I want to present for chapter 4 result discussion. 4.1 transfer function of the heat. The thermal of water heater, we assume that the tank is insulated to eliminate heat loss to the surrounding air. There is no heat storage in the insulation, and the heat in the tank is kept at uniform temperature by mixing with the help of a stirrer. Thus, a signal temperature is used to describe the temperature of the liquid in the tank in outflow. The next is for the system gain K from 0 to infinity. The root locus is the position of the roots of the characteristic equation. The closed loop control system stability system using the approach. The closed loop system is depicted in figure 4.2 below. K is a changeable parameter that is a part of the system forward path. As a result, the root locus is defined as the location of the pulse of the closed loop control system at 10 for a range of K value from negative infinity to positive infinity. However, it is typically believed to be in the range of 0 to. As a result, the method aims in establishing system stability and is used as a stability gradient control theory. The form for 4.3 analysis on time response is Simulink and MATLAB value for the PID controller to be used in the system is the time response analysis graph was project. And for 4.4 analysis on frequency response, this system's frequency response study may also be done using MATLAB and simulation. The steady-state response of a system to an input sinusoidal signal is called the frequency response. A linear time invariant LTI system generates sinusoidal signal as its steady-state output if a sinusoidal signal is provided as the system's input. The frequency of the input and output sinusoidal signal is the same, but their amplitudes and phase angles are not the same. In order to obtain the desired result of the frequency response analysis graph for this water heater system, the settings tuned in PID block parameter for the frequency response analysis has an adjustable value from the simulation in MATLAB and Simulink. And the last is I want to present our chapter 4 result and discussion is for the 4.5 stability analysis of PID in industrial control system and other application that call for continuously modulated control. A proportional integral derivative controller. PID controller is a control loop mechanism that uses feedback. A PID controller constantly calculate an error value represented by the letter P, I, and D as the difference between a desired set point on input denoted by the letter RT and a measure process variable. This is the block diagram of 4YMD controller. That's all for me. Thank you. And the last is I want to present our chapter 4 result and discussion is for the 4.5 stability analysis of PID in
Okay,
industrial.
hello, my name is Kishore Kumar and my matrix number is AD210107. So I am going to be presenting about the conclusion of our project. This control engineering project aimed to improve our water heater's efficiency using a closed-loop system. Key objectives involve measuring heat, calculating temperature errors, employing fuzzy logic for decision making, and regulating power supply. The project showcased practical control engineering in a real-world scenario with a functional block diagram illustrating component interactions. Fuzzy logic allowed adaptability to uncertainties, enhancing the system's robustness. Successful implementation, especially with KP30, KI200, and KD6, which we found is demonstrated the present prevention of steady-state errors, emphasizing the technology's potential in optimizing heating efficiency. So we have come to the final part of our presentation, which is the recommendation. This project utilizes a PID temperature control system, demonstrating accurate performance in maintaining temperature. However, it acknowledges a narrow focus on outcomes without considering factors like response time and energy consumption. Due to space and budget constraints, the study addresses only basic water temperature management, highlighting the need for more comprehensive investigations into system efficiency improvement. The project suggests future research directions emphasizing the complexity of real-world control problems, particularly in handling multiple water tanks. Additionally, it underscores the importance of exploring remote control and monitoring setups for PID approaches in industrial applications.